to connect between us, okay? Because in this case, we have an online course, unlike last year that we have teaching on site. First of all, in your chat, I have sent you the link to Google Form. And I would like everyone to go to that form and fill out your name, your ID numbers, your phone numbers, and all the information, email. I will use that as a record and all as a way to interact or send you some information, including some of the homework and quiz for you to work on. Okay. During our class today, please make sure that you fill that form and tell your friends that to fill this form before you leave, because I will also use this as an attendance check for being in class today. Now, let's look. Okay. Okay, someone said that they have signed up for the class but didn't show up. Don't worry, it will take some time before everyone's name come up in regular. And at least you get to the form that I given and then you sign it up, it will be okay. Okay. Let's see. First of all, I would like you to see this. This is the course syllabus. It will be from last year, but pretty much this year is the same. This course title is Essential Physics. Okay, it's 3 credit hours. It means that we have lecture times 3 hours per week, and today on Tuesday it will be 1.5 hours from 10:30 to 12, and tomorrow it will be from 1 to 2:30 on Wednesday. And it is a semester course, letter and method of measurement will be letter grade. My name is Sathon Vichan Vanalak. Okay, I will teach the first half for the first 7 weeks. And then after midterm, there will be Dr. Anop Ektarawong. He will teach the second half. Well, let's take a look at the course description a little bit. For the first half, it will be basic mathematics in physics, mechanical motion and fundamental laws of mechanics, which means the Newton's law of motion. Work, momentum and energy, conservation of energy and momentum, collisions, oscillation, angular simple harmonic motion, fluid mechanics, vibration and wave, and then physics of sound, Maxwell equation, electromagnetic wave, polarization of light, interference and diffraction of light, blackbody radiation, photoelectric effect, spectral lines, wave particle duality, radioactivities, ideal gas, or equipartition of energy, and two law of thermodynamics, which means the first and the second law. Now, as objective to this class, okay, that, okay, the objective of this class, after you finish the class, you should be able to describe the motion of particle, system, and rigid bodies, okay, and calculate the physical quantities that is relate to the motion. Well, second objective is to understand the concept of conservation of energy and apply to solve the problem. And then describe the type of wave with their properties and oscillatory motion. Okay, be able to connect the concept to many phenomena, and then understand the concept of Maxwell's equation, which is strange because in order to understand Maxwell's equation, you need to understand the concept of electromagnetic induction first. But in our course syllabus, it doesn't show anything about the electricity and magnetism. So possibly this is a basic concept, okay? Describe the interference and diffraction phenomena in principle, understand the basic concept of quantum mechanics, and then understand the ideal gas properties of ideal gas and basic concept of thermodynamics. Then there are two, like the general objective. You should be able to do literature search and study independently. Now, this is the chance because since we have COVID-19, our class have to be online. And that means you relied on yourself more than just having the class in lecture. Then, well, number 9, it is hard to predict. Having the right moral and ethics. At least one thing, to be on time for the class, can we say that you have good ethics of work? So we will see that this objective possibly cannot measure directly. Now, let's take a look at the content. This first week will be the basic mathematics in physics and motion in 1 and 2 dimension. And then next week will be about law of motion. I'll try to follow this guideline, but however, I feel that sometimes rearranging the subject might help you understand the topics better. So it might not going as this class, as it said here, but I will make sure that it will cover every topic that we have in this one. So I will teach the first, I believe the first 6 weeks, okay, until oscillatory motion. And then Dr. Arnab will follow as the later. Teaching media, well, I cannot write on the blackboard anymore. So it will be through PowerPoint and using Zoom as our media. Now, required text, okay. I use a lot of books in teaching first year physics class, and two of them are in this list, and that is the Raymond A. Survey Physics for Scientists and Engineers, and then another one is David Holliday and Resnick and Walker, Fundamental of Physics, 7th edition by John Wiley and Sons, 2004. These two books is you can call it the Bible. It is lay the foundation of general physics. Now, between the two books, there are some special characteristic in each book. Survey tend to start from the ground up. The problem will be quite easy at the beginning, and then it will gradually come up harder as you going from the first to the last question. And they have some essay to read about the application of each chapter. So you will find it interesting to read in case of you want to know some things more about the subject. Okay. On the other hand, Holiday have a distinctive topic section that is called check quiz question checklist. There are some small questions inside the book that check your concept of working on of understanding of the topic. Now, if you can answer that question, it means that you are on the right track. And some of that checklist question is quite interesting, and some of them I use as a question in my exam. So that is the two of the books that I'm familiar with. Now, if you prefer to read it in Thai, Physics and Integral by Dr. Somchai, this also will help you about some of the calculus topics in this class. Now, evaluation, well, they don't say it here, but I will tell you this. Because we have two lecturers, I teach the first half and Ajahn Anop teach the second half. So we split the total score. I will take 50% of the first half, and Ajahn Anop takes another 50%. Now, as of now, we will have 10% set aside for attendance and quiz. So please come to class regularly. I will have the ways to check out your attendance by, for example, by just let you fill out the form just like today, or I will have some small quiz to check your understanding, and it will use as the attendance list also. So suppose if it was a quiz, there will be some marks on that is regarded as attendance, and then there are some extra marks that based on the question that we ask. So nobody gets 0 point out of the quiz, and that means that you always have some point doing that, and that will be set aside as the first 10%. Now the other 40% will be due to the test, and because the situation as of now, July have set up the guideline that all of the tests should be online. So we have to work out the way to set up the test with another class. There are two groups of students study this class. We are in BSAC, and the other class that will teach study this one also is BB Tech. They will have the class at the same time as us. The grading will be together and the exam will be together. So we use the same set of exams. So in that case, that 40% will have to discuss between two groups of students first. Okay, so as of now, I can give you that I will have some attendance check and it will be 10% out of my 50%, and then the test will be another 40%. Okay, any question about the syllabus? Okay, any question about syllabus? Nope. Okay, let me check something here. Okay, now there are 45 responses on the list. Okay. Let's share another things. To help you with the subject, I have created a Facebook page. It's called 2304-151 Essential Physics BSAC. For our class, okay, as of now, only 2 people like this, which means me and Ajahn Nop. So let's see what we have in here. We just have one thing. I have a Google Drive link here. It's called 2304-151 Essential Physics. And if you click on this, it will lead you to a class note that I have last semester, okay, which is the class note that I teach, and I will use this class note also in this semester. So I share this for you to read before class, before we have the class next time. The total is 89 pages, so possibly we will have something more during the time that we have this class for the next 6 weeks. So this is some things that you need to you can read before. Other things is that this page will be something that like our connection. So if you have any question, feel free to drop by on this page so that not only I can solve it, but your friend can solve it also. And I will try to answer it as quickly as possible. Okay. So not that one. So that is the page that we can use as our means of connection. Okay, that's two things. Any other question regarding what we discussed so far? Let's hear your voice. Anyone have anything to ask or to share with our friends?
Excuse me, Professor. I can't find the Facebook group on the Facebook page.
Okay. Let me send you a
Somehow.
link.
Okay, thank you.
So let's try this one. Okay. Oh no. To everyone. That's the link for the Facebook page for you to see. Now, unfortunately, the first one we discussed today wasn't on the Facebook page, but I will upload it later after we finish our class today. So okay. Let's get into our subject. Okay, this class is called Essential Physics. The class ID is 2304-151. And well, this section is taught by myself, Sathon Vichan Ranarak. Okay. And that is also my Facebook name. If you want to add me as your friends, that will be my Facebook page name. First of all, before we going into physics topic, today we will discuss some mathematical ideas that will be used in this class. And that is about the vectors and a little bit about trigonometry and a little about calculus. So in terms of vectors, what you need to be able to do is that you should be able to write and explain some vector properties and demonstrate addition and subtraction of two or more vectors in graphical ways and also in mathematical way. Write vectors in terms of summation of other vectors, especially in rectangular coordinate. And then you should be able to add and subtract vectors in rectangular coordinates, and then finding the resultant vectors. Now there are another two properties that is very important in physics, and that means the scalar products of the vectors and a vector products of the vector. And that means the multiplication concept. Okay, we have addition, we have subtraction, and then we have the multiplication. And in terms of vectors, there are two types of multiplication. A vector multiplied by another vectors and have a result in scalar number. Okay, or a vectors multiplied by vectors and then get the result of another vectors. So there are two types of multiplication, unlike normal math that we have only one type. 2 times 3 is 6, and that is a math question. But then in terms of vectors, vectors of 2 units multiplied by vectors of 3 units doesn't mean that it gives you as a vectors of 6 units. It has another properties. So that is the big pictures. Now, when we say it's about vectors, we should be discuss about the notation used and what is a vector. A vector is a quantity that contains both magnitude and direction. Okay. Let's see if I can have this. Now, when we say about vectors, we draw pictures. This is vector A. And the magnitude is the length of A. Is the length of vector. And direction is related to the arrows. This is direction. So in terms of what vectors are given is that there are two quantities that each vector gives. It gives magnitude or the length of it and the direction or which way it goes. Now, if you don't have only one quantities, it means that the magnitude only that is the scalar. So let's see what is the vectors and what is the scalar. Let's add another table here. Okay. Have it here. Here. This is scalar. This is vector. Some things about scalar is mass. This is scalar. Temperature. Okay. What else? Actually current. Vectors is displacement. Scalar is distance. There are the difference between distance and displacement. Scalar is speed, but if it velocity, it will be vector. Electric field, magnetic field, this is vector quantity. Momentum, force, this is example of vector quantities. And on the left is the example of scalar quantities. Now, when we write vectors as a symbol in mathematics, we use the capital letter with an arrow on top. Okay. Here is vector A. Is A with the vectors on top. We read it as vector A. Now, when we want to talk about magnitude of vector A, okay, let's change it back to pen. When we want to talk about magnitude of vector A, let's move it as red. Magnitude of A can be written in two ways. Is by putting an absolute sign on both sides of vector A, or just by remove the arrow. Okay, this is called magnitude of A. Now, there are special types of vectors. This is special types. It's called unit vectors of A. The unit vectors of A has magnitude equal to 1. And it is same direction as A. Okay. It has the unit vectors of A. There are three very important unit vectors, which is called I, J, and K. This is unit vector in Cartesian coordinate. I is pointing toward X direction, so sometimes they call it X. J is Y and K is C in 3 unit vectors. So this is typical vectors This is vector AB. You can say that this is vector AB. And this is vector A prime B prime. And this is A double prime B double prime. In order for this to be equal, there are two reasons. It must have the same magnitude. That means it's the same length. And it must have the same direction. It means that it points to the same direction. And in that case, we will say that AB is equal to A prime B prime and equal to, let's remove this. AB is equal to A prime B prime and equal to A double prime B prime. These three vectors are equal. Okay. This is the concept of equal vector. Now, when you want to add vectors, the concept is like you playing treasure hunt. Or when you play treasure hunt, it says that walk to the north 5 steps and then turn right, walk another 30 steps, something like that. You have to finish the first stage before you enter the next stage. And that is also the concept of vector addition. So if you write D1 plus D2, you draw a vector D1 first. And then at the end of vector D1, you draw another vectors D2. And the addition vectors D1 plus D2 is starting from the starting point of D1 and ending at the ending point of D2. So in this case, this is the vector D1 plus D2. In graphical idea. Okay. In graphical idea, you doing this. And you will see that suppose this is D1 and this is D2. You have that the vector D1 plus D2 is this one. Now, if you draw a D2 first, this is parallel to the one on top, and draw a D1 second, you will see that it will end at the same point. And so this vectors is not only D1 plus D2, but it's also D2 plus D1. So addition vectors having a properties that you can switch the order. This is properties of vectors. You can switch the order D1 plus D2 equal to D2 plus D1. Now we use this a lot in motion, okay? And this is the difference between the difference of displacement and the distance. The length of the actual path, so this is somebody moving from A to B and from B to C. First, they move along the red line. Okay. Object move along the red. Ouch. Okay, somebody send a chat. Oh yes, I will post this slide on Facebook page after we finish. Okay. Object move along the red line. So the length of the path is called a distance. Okay. If you take the red line and measure the length of the red line, that is the distance. It is a scalar quantity. However, we define another things as displacement. Displacement is a vector from starting point to ending point. Okay, so in that case, displacement is vector AB. Now, after arrive at B, they move again along the red line to C. So the displacement of BC is also this point. So the net displacement is the vector sum between the two. So this is the S, okay? Net displacement usually sometimes called S. And one thing is that the magnitude of displacement is not equal to distance. Because the magnitude of displacement is the straight line, but the actual movement distance is the red line. So it's not equal. Usually it is smaller. Okay. And this is commutatively, we have discussed it earlier that from vector properties, the vector sum, they have a commutative. So A plus B is equal to B plus A. You can switch the sum. However, for subtraction, it's not working that way. And it's also have associativities. For example, if you have three vectors A, B, and C, if you draw vectors of A plus B first, having a green one, and then add C's, you have the resultant vectors as this. So you can doing it by A plus B and then plus C. Or you can doing it by add B plus C first So B plus C is this one. And then you added A. Okay. So in this case, you see that in terms of vector, A plus B plus C is equal to A plus B and then plus C. Well, you don't have to, you can doing each one first. And also you can say that it is also equal to A plus C plus B. Okay. That is a associativity concept. Now, opposition vectors. Opposition vectors means that if two vectors have the same magnitude, but point in opposite direction, we call it opposition vector. And write as negative. So, for example, negative B is opposition of B. Or in the other hand, if you say that C plus B is 0, then C is equal to opposite B, and that means C is opposition vector of B. Because when you add opposition vector to any vectors, the resultant vectors will be 0. It will cancel each other out. Okay. So if you have C plus B equal to 0, then C is the opposition vectors of B. So it's point in the opposite direction with the same distance, with the same magnitude. This is called an opposition vectors. Now, what is it so important? If you write D as A minus B, it's a vector subtraction. You can rearrange it to be A plus negative B. So it is A plus to the opposition vectors of B. So if this is A and this is B, the opposition vectors of B is point the opposite way. So this is negative B. So A minus B is actually A plus by opposition vectors of B. So head to tail. Okay, the answer is this one. Now, B is actually point this way. This is B. So this is A plus B. This is A minus B. This is the opposition vector. So a subtraction vector is by adding it to the opposite direction. Now, you can see that any vectors can be drawn in terms of two vectors addition. For example, suppose this is vector A. You can say that it is B plus C. This is A equal to B plus C. Now there are one ways of drawing it. The very important vector addition is that suppose A is a vector, you can draw two vectors that are perpendicular to each other. And we call the horizontal vectors AX and vertical vectors AY. And then we can say that A equal to AX plus AY. And this is formed into a right triangle. Okay. When it is in right triangle, we found that there are two things. The Pythagorean theorem states that the square of the two lengths, the square of the side opposite to the angle, plus the square of the side adjacent to the angle, equal to the square of the side opposite to the right triangle or the hypotenuse. We call this side hypotenuse. This side is opposite. And this side is adjacent. So we have Pythagorean theorem state that AX square plus AY square equal to A square. And this is trigonometry. The ratio between the opposite to the hypotenuse is called sine of theta, sine of the angle theta. And the ratio of the adjacent to the hypotenuse is called cosine theta. So this is another relation. So suppose you go ahead and looking at trigonometry. We say that for a right triangle, the sine theta is the leg opposite to angle theta divided by hypotenuse. And the cosine theta is the leg adjacent to the angle theta divided by hypotenuse. And tan theta is the leg opposite to angle theta divided by leg adjacent. So in that case, we can also break the vectors. Okay, this is the value for sine, cosine, and tangent for any angle. So let's review it a little. So if this is theta, this is sine theta, and this is cosine theta, and this is tan theta. Some of the angle that we frequently use is that 0, sine theta is 0, cosine theta is 1, tan theta is 0. If theta is 30 degrees, sine theta will be 1/2, cosine theta will be square root 3/2, and tan theta will be 1 over square root 3. Okay. Tan theta is opposite divided by adjacent, but then it is opposite divided by hypotenuse times adjacent divided by hypotenuse. So it is a sine theta divided by cosine theta. (37 degrees), this is 3/5, this is 4/5, and this is 3/4. 45 degrees, this is 1 over square root 2, this is also 1 over square root 2, and this is 1. 53 degrees will be the opposite to that. This is 4/5, this is 3/5, and this is 4/3. 60 degrees, this is square root 3/2, this is 1/2, and tan theta is square root 3. And then 90 degrees, sine theta will be 1, and cosine theta will be 0, and this will be infinite. You see that 90 degrees, this is infinite. And then it will repeat itself from minus infinite to plus as the angle going after. So that is a value of sine, cosine, and tangent. Now, this is a component vectors. Because of that, okay. Okay, component vectors is A equal to AX squared plus AY squared. We can say that any vectors of A can be written into two vectors AX and AY that are perpendicular to each other. AX is along the x-axis and AY is along the y-axis. It is forming a right triangle. So we have three relations, and that means the length of the AY according to trigonometry, AY is AY divided by A is sine theta. So according to trigonometry, AY divided by A is sine theta. According to trigonometry, we have the magnitude of AY is actually the magnitude of A sine theta. And also the AX is over A is cosine theta. So the magnitude of AX is A cosine theta. And also according to Pythagorean theorem, a square equal to ax square plus ay square. Okay. Now, if we're doing a addition, for example, if we're doing addition of the two vectors that is perpendicular to each other, this is for vector addition. This is an example. Sorry. Should write it down here. Which means that if Bx is 7 meters, this is not a vector, this is magnitude of Bx is 7 meters, and magnitude of By is minus 5 meters. Means that it's going into the negative x direction. Find B, magnitude of B, and angle to x-axis. Okay. For example, if we want to find the B, we use Pythagorean theorem, b squared equal to bx squared plus by squared. So bx is 7, so you get 7 squared. And by is minus 5, so got minus 5 squared. So it is b squared equal to 79 plus 25, and that is 74. So b is square root of 74 of 8.6 unit, or 8.6 meters. Now, that is the length of b. This is unit in meters. So that length is 8.6 meters. Now, angle, we know that tan theta is actually sine theta divided by cosine theta. And that is actually b sine theta divided by b cosine theta. And that is by divided by bx. So it is minus 5 divided by 7. Okay. So minus 5 divided by 7 is minus 0.71. So theta is arctan of minus 0.71. And that gives you minus 35.5 degrees. Or 324.5 degrees. So this is 324.5 degrees. Now, if you measure it this way, this is negative 35.5. Okay. When we measure the angle, we always doing it counterclockwise to have the positive angle. Okay. So according to angles here, is moving this way. This is 0, this is 90, this is 180, and this is 270, and that is 0. So it's going that way in positive direction. So in that case, it means 324, or you can say that it is negative 35.5. And that is an example of how to add vectors up if it's a rectangular. Now, in this case, they say this is another example. I just draw, I didn't write. A plane is moving 215 kilometers, making an angle of 22 degrees to the north. So this is north. What is the direction or distance in x and y axis that the plane travel? So we know that the magnitude of the plane D is 215 kilometers, and theta, this is 22 degrees to y-axis. So we said, oh, no, this is alpha. This is angle alpha. So the angle to the x-axis is theta, which is 90 degrees. 90 degrees minus 22. 90 minus 20 is 70, minus another 2 is 68 degrees. So dx is d cosine 68 or d sine 22. So if we get d is 215 and sine 22 or cosine of 68, it will give you a distance of dx equal to 80.5 kilometers. And dy is d sine 68 or d cosine 22. And this gives you dy is 199 kilometers. Okay, so that is another example of finding a distance in the x and y axis. Now, when we're talking about unit vectors, I introduced you earlier that there are 3 important vectors. That is the unit vectors along the x-axis. We call it I or x, unit vectors. And a unit vectors along y-axis, which is j. And the unit vectors along z-axis, which is k. So this is I, this is J, and this is K. Or sometimes they call it X unit vector, Y unit vector, and C unit vector. Depending on which book you read, they will have three different notation. How are these so important? Because any vectors can break it into three vectors. So any vectors A can break down into AX plus vector AY plus vector AC. It is in three vectors that are always perpendicular to each other. And in terms of unit vectors, you can write it as AXI plus AYJ plus ACK. AX is magnitude of A along x-axis. And AY is magnitude of A along y-axis. And AZ is magnitude of A along C-axis. So you can break it into three vectors. So A can break it into AX plus AY and then plus AC. And draw it like this. You break it into three vectors. So in any vectors can be written in terms of these unit vectors. As just like this. So this is called the vectors in rectangular coordinate. A equal to AXI plus AYJ plus ACK. And this is unit vectors along X, and this is a magnitude. So now if you have two vectors, okay, A written in terms AXI plus AYJ plus ACK. In the same way, if you have vector B, B can also be written as BXI plus BYJ plus BCK. Now in terms of addition vectors, A plus B, okay, is you can just add it along the same axis. So X and X is going in the same direction. So A plus B is to be AX plus BXI plus the AY plus BYJ and AC plus BCK. In terms of subtraction, you can also write A minus B as AX minus BXI plus AY minus BYJ plus ACK minus B, C, K. And you see it first thing is that A plus B is equal to B plus A. But A minus B is not equal to B minus A. Because if you take a look at this, you see that B minus A is Bx minus Ax I บวก plus by minus byj by minus ayj. Then plus bc minus ac k, which if you switch between the two, it is negative of ax minus bx, negative of ay minus by, and negative of ac minus bc. Or you can see that b minus a is actually negative of a minus b. It is the opposite direction. Okay, that is the addition and subtraction in rectangular coordinate. So now we are going to the last topic. It's called vector products. Vector products or multiplication of vectors, there are two types. The first one is a scalar or dot product, written as A dot B. And the other one is a cross product or vectors product, or it's called A cross B. This is read as dot. And this is read as cross. Okay. Now, a scalar product is a magnitude of a vectors. It is a product of magnitude of vectors in another direction. So in the direction of the first one. So A dot B means vector A times vector B is in the direction of A. So suppose you have, this is A and this is B. And this angle is fine. You see that this is a vectors B in direction of A. So B cosine phi is vector B in the direction of A. So A dot B is magnitude of A times magnitudes of B in the direction of A. So it's B cosine phi. But it also means that if you have this is an A and this is B as the same, this is also fine. This is also A cosine phi. So it's also the magnitude of A cosine phi times B. And because they are the same, we say that A dot B is equal to B dot A. Okay, so that is dot products. Now we have a relation that if there are two vectors that are in the same direction, for example, I dot I, J dot J, and K dot K, it will give you a 1. Now, if it perpendicular to each other, I dot J, J dot K, and K dot I is also 0. Because they are perpendicular. So I dot I, you can see that I dot I is 1 times cosine of 0 degrees. So that is 1. But I dot J is magnitude of I is 1, magnitude of A is 1, but this is cosine of 90 degrees because they are making a right angle to each other. So this is 0. So if you have A dot B and you have A equal to AXI plus AYJ plus ACK, and B equal to BXI plus BYJ and BCK, A dot B, if you multiplied it together, you got AXI times BXI, BI dot I, and then it's a cross one between AX and BY, and then I dot J. You will see that the only terms that left is not 0, is AX times BX, and AY times BY, and then AC times BC. And this is called scalar product for rectangular coordinate. This is the scalar product. We will use this product a lot in terms of work and energy, in the topic of work and energy. Okay. Now, a vector product is another hand, is a multiplication of vectors and resultant in a vectors, another vectors that are perpendicular to the first one. So if this is A and B, the magnitude of vector products is a magnitude of A times the magnitude of B that are perpendicular to A. So this is A and this is B. This is also B sine phi. So a vector, a magnitude of A cross B is A cross B sine phi. And the direction of cross product is making a right hand rules. This is A cross B. A cross B, according to right hand rules, is perpendicular to both A and B. Okay, so it doesn't have commutative. A cross B is equal to negative of B cross A, just like the subtraction. So here's how to find the direction of cross product. Use your right hand, point your palm, your hand in direction of A. and making a fist by rolling your 4 fingers, index finger, middle fingers, ring fingers, and pinky, the last one towards B. Your thumb will showing the direction of A cross B, according to these pictures. Now, if you're doing a B cross A, you put your palm towards B and roll it back to A. And you will see that these two cases, A cross B and B cross A, are pointing in the opposite direction. Okay, and that's how to find the direction of cross product. And the magnitude of cross product is A times B cosine sine phi. For example, this is A and this is B. In these pictures, A is along the X and Y axis and B is along the Z axis. And the direction of C, according to right-hand rules, point your fingers toward A and roll it to B and give you an A equal to C cross B. So it's just like this is your hand, your right hand, and then this is point towards A, and then roll it up towards B. This is your thumb, this is C. And in rectangular coordinate, you will see that because I, J, K are perpendicular, I cross I and J cross J and K cross K will give you 0 because they are in the same direction. But I cross J is K and J cross I is negative K. J cross K is negative I and K cross J is negative I in this manner. So if you're doing a cross product by multiply cross between A cross B, you have 3 in each one, AXI, AYJ, and ACK, BXI and BYJ and BCK cross together. After multiplication, you get 9 terms. Of 9 terms, 3 terms will equal to 0 because I cross I is 0, J cross J is 0. The other 6 will give 2 terms along the I axis and 2 terms along the J axis and 2 terms along the K axis. And I left you for this to work on your own. But the result will see that A cross B will give you this. Okay. Or you can do it by finding the determinant along this axis. So it's 5 minutes past 12. I believe I spent too much time on this one. But however, tomorrow we will finish this PowerPoint, which is, and then about basic calculus, some things you need to know, and some others relation. And then we will start our discussion. Okay. Oh, wait, shit. I forgot to record this one, so sorry about that. But this slide will be posted on the course, on the page. Tomorrow will be discuss the motion and finish with this. Okay. Okay. So in that case, see you again tomorrow. I will not forget to record the course next time. Sorry about today, but I hope I will see you again tomorrow. And tomorrow we will have a little small quiz about the topic we discussed today. Thank you very much for your attention. I will see you again tomorrow. Goodbye.
Thank you.
Goodbye.
Bye.
Thank you.